6 children swim a 50-metre race. Who finished first? Now remember, the person who finished first will be the person who completed the race in the shortest time. So here we can see we've got 4 numbers with 8 tens, so if we look at our ones digit, we have 6, 5, 4 and 9. So this person with 84.7 will have finished first, and if we look across, we can see that that's Jodie. Now, how many seconds faster was Dean than Fiona? So here, we're comparing 2 different times, and when we're comparing times, we need to use subtraction because we're finding the difference. So we can see that Dean completed the race in 89.2 seconds and Fiona in 90.4 seconds. So if we subtract, we can use column subtraction. We need to remember to line up our decimal point in our answer, and then when we use column method, we get 1.2. So Dean was 1.2 seconds faster than Fiona. Here is part of a number square. The shaded numbers are part of a sequence. Explain the rule for the sequence. Now you can see that we're going down and left each time, but we can't write go down and left as our rule, because if you need to write a rule for a sequence of numbers, then you need to write that rule in terms of add, subtract, multiply or divide. You can't use words like up and down. So if we look at what's happening, we have 116, 125, 134 and 143. So we're adding 9 each time, because the way this number square works, when we go down we add 10, and when we go left we subtract 1, and if we add 10 and subtract 1, we've added 9. So the rule is add 9. Now you could look at this sequence the other way, so you could, instead of starting with 116, start with 143, and then the next number would be 134, so this time it wouldn't be adding 9, but subtracting 9. But as long as you recognise that the numbers in the sequence will have a difference of 9, you'll get the answer right for this question. Shade 1/5 of this shape. Now this question is confusing because we need to shade 1/5, but our shape hasn't been divided into 5 pieces, it's been divided into 1, 2, 3, 4, 5, 6, 7, 8, 9, 10 pieces. So what we need to do here, to find out how many pieces we need to shade, we need to find an equivalent fraction which has a denominator of 10, because we have 10 pieces in our shape. Now 5 times 2 is 10, 1 times 2 is 2, so because 1/5 is equivalent to 2/10, we need to shade 2 of these pieces, 2 of these tenths. So when we do that, we've shaded 1/5 of the shape. Liam has 5 coins. 3 of the coins add up to 30p. 3 of the coins add up to 40p. All 5 coins add up to £1. What are the coins that Liam has? Well, first, let's think, how can we have 3 coins that add up to 30p? We could have 3 10p's, because 10 plus 10 plus 10 makes 30. Or we could have something else. We could have 1 20p and 2 5p's. Now, let's think what 3 coins add up to 40p. Well, here, it must be a 20p and 2 10p's, because that's the only way to get 40p. So already, we know what 3 of these numbers must be. One of them, at least, must be 20p, and 2 of them, at least, must be 10p. So, let's start with 50p, and then we can have 20p, 10p, 10p, and then if we look at what we've got so far, we've got 50 plus 20 is 70, plus 10 is 80, plus 10 is 90, so we need another 10p to make sure it adds up to £1. Now let's look at these numbers and see if they fit the rules that we've been given. We can see that 3 of the coins, these 3 coins here, add up to 30p, and we can see that these 3 coins here add up to 40p, so we have our answer. Some children collect cans for recycling. Here is a chart of how many cans they collect in the first week. How many cans has Kevin collected? We can see that we've got children's names on the side, and then at the bottom we have the number of cans. But this scale clearly isn't going 1, 2, 3, 4, 10. If we look, we have 1, 2, 3, 4, 5 jumps to get to 10, and 10 divided by the 5 jumps means that each jump must be a jump of 2. So this scale is going up in 2s, and that makes sense because we have 2, 4, 6, 8, 10. Now we want to know how many cans has Kevin collected. So we can find Kevin, and if we go across to the end of his bar, what we can do is draw a line straight down, and then we can see that it's between 16 and 18, so Kevin must have collected 17 cans. Now Alice's target is to collect 30 cans. How many more cans does Alice need to reach her target? So again, we can find the bar, so find Alice, and if we go to the end, draw a line down, we can see that Alice has already collected 12 cans. But she wants to collect 30 cans. So here we need to find the difference between two numbers, so we need to subtract. 30 minus 12 is 18, so Alice needs to collect another 18 cans. She's collected 12, and if she collects 18 more, then she will have reached her target of 30 cans. How much water is in this container? Well, if we look at the water level, we can see that it's in the middle of 400 and 450 millilitres. Now, if we divide 50, so divide the difference by 2, because we have 2 lines to get from 150 to the next, if we look at the bottom of our scale, we have 2 lines to get from 0 to 50. 50 divided by 2 is 25. It's useful to know that, but if you don't, you can always divide using short division. So that means with each line, we go up by 25. So we have 0, 25, 50, 75, 100, 125, 150, and so on. And that means the number in the middle of 400 and 450 is 425. So we have 425 millilitres of water in our container. Look at these digits. We have 3, 5, 8 and 7. Use the digits to make the largest possible even number. Use each digit once. Now we know that when we're making the largest possible number, we need to have the larger digits in the larger place values. So normally, to make the largest number, we would have the largest digit in the thousands place, the next largest in the hundreds, the next in the tens, and then the smallest digit in our ones. But this question is a bit more confusing, because we don't just want to make the largest possible number, we want to make the largest possible even number. Now remember, an even number is a multiple of 2, so a number that ends in 0, 2, 4, 6 or 8. And the only even digit that we have on our cards is an 8. So we know that 8 must be our ones digit, because that's the only way that we can make an even number from these digits. So now that we've written the 8 in our ones, we can write the largest remaining digits in the larger place values. So 7 is the largest digit because we've already used the 8, so we can have 7 in our thousands, then 5 in our hundreds, and 3 in our tens. So we have 7,538. We need to complete the table. So we have numbers written in Roman numerals, and we need to write the number that each of these Roman numerals represents. So we need to remember that with Roman numerals, C stands for 100, L is 50, X is 10, V is 5, and I is 1. And that makes sense because if we have LX, we have 50 and then 10, and 50 and 10 make 60. So now we have LXXVI. L is 50 and X is 10. So if we have 50 and then 2 tens, we have 70. But then we have a V and an I. So we have 5 and then 1, which makes 6. So altogether we have 76. LXX is 70 and VI is 6. Now we have XCIII. Now X is 10 and C is 100. So we have 10 before 100. So we need 10 less than 100. 10 less than 100 is 90. So XC stands for 90. Then we have 3 I's, so that's 3 ones, which means our number is 93. XC is 90 because that's 10 before 100, and then I is 3. Here is a row of numbers. We have the numbers 1 to 18. Find 3 numbers next to each other which add up to 39. Draw a ring around them. Now for this question, we could use trial and error. And by trial and error, I mean just trying out something, seeing if it works, then if it doesn't, trying something else. So trying out 3 numbers, then if the total is less than 39, we might try out 3 bigger numbers. But we know that 10 plus 10 plus 10 is 30. So there's no point trying numbers less than 10 because the total will be less than 30, and we need numbers which total 39. So we could start trying out combinations that are larger than 10, so perhaps 11, 12 and 13, or we might spot that if we have 3 times 13, or 13 plus 13 plus 13, we'll get 39. And that means that 12 plus 13 plus 14 must also be 39, because we've made this first number 1 smaller, this third number 1 larger, and that means that we'll get the same total. So our numbers are 12, 13 and 14. Write numbers in the boxes to make this calculation correct. We have 50 minus something equals something plus 10. So for this question, we need to remember that the equals sign means has the same value. So we need to make sure the calculations on both sides of the equals sign are the same. Now because we have 2 unknowns, because we have 2 empty boxes, there are lots of possible answers for this question. So what we can do is just put in a random number in one of the boxes and then make sure the other side gives the same total. So if we put 10 here, 50 minus 10 is 40. So 40 equals something plus 10. Well, 30 plus 10 is 40. And then we've got the same total on both sides. 50 minus 10 is 40, and 30 plus 10 is 40 as well. So we could use 10 and 30 as our missing numbers, but there are lots of other possible combinations as well. So if we did 50 minus 20, that would be 30. So then we would have something plus 10, and it would need to total 30. Now 20 plus 10 is 30. So if we have 50 minus 20 and 20 plus 10, because they both equal 30, we can say that they're equal, so we could use 20 and 20. Or we could have 50 minus 0, that would be 50, and 40 plus 10 is 50, so we could have 0 and 40. Or we could have 50 minus 1, that's 49, And 39 plus 10 is also 49, so we could have 1 and 39.